All right, good morning, everybody. It's really nice to see everyone, those of you in person and those of you on Zoom. We're really excited. Again, we're excited every week because we have such great alumni. This is really fun to be able to do. We have 3 of our alumni who are joining us today from the fields of generally like regulatory and policy type of applications within industry and government. And so I think this will be a really exciting group to hear from. This is not a set of an area that we usually hear a lot about for chemical engineers who've done their training in chemical engineering and then gone into this area. So we're really looking forward to having Kelly and Brittany and Trevor share about their experiences and their work. It's really my pleasure to introduce Professor Bagari, who is one of our faculty who's cross-appointed between biology, chemical engineering, and the Allen Institute. So has a really cross-disciplinary, interdisciplinary set of research and expertise that she brings to our department, and she will be our moderator today. And I will hand it over to her and just remind everybody to use the Slido, which I'll post in chat and put up the QR code for everybody in the room to use to ask questions to our panelists. All right, Netta, handing it off to you and muting myself.
All right. Thank you for organizing, Elizabeth, and thanks everyone for being here. I'm thrilled to be moderating this panel. It's a really exciting topic, sort of thematic area that I imagine sort of pulls from a lot of different disciplines as well. As Elizabeth mentioned, so I have a very sort of diverse interdisciplinary background, electrical engineering, chemical engineering, biological engineering. I graduated from University of California, Santa Barbara with my PhD in 2007, and then from there went to MIT for my postdoc, and then started my faculty position at Northwestern University, and then moved over to the University of Washington. So I've also sampled a lot of different academic environments as well. And I'm just absolutely thrilled to have Brittany here, Kelly, and Trevor. So Brittany is a program officer with the Transportation Research Board at the National Academies of Sciences, Engineering, and Medicine, where she's worked since September of 2021. Kelly is vice president at Boundary Stone Partners and executive director of the newly formed Institute for Transportation Decarbonization. And Trevor is the flow sheet integration manager for the low activity waste facility at the waste treatment plan project at Hartford site in Richland, Washington. And so at this point, I would love to invite the panelists to give a brief introduction to themselves. Yeah, so let's start with Kelly.
Sure, thank you. So my name's Kelly Flemming. I currently live in Washington, D.C., where the State of the Union is happening tonight, causing traffic issues. I am originally from Colorado, and I graduated from University of Washington with my PhD at the end of 2015. I was in Jim Fentner's group, working on computational research. Following that, I ended up doing the AAAS fellowship, which I'm sure I'll talk about a lot today. And I think that's kind of how I ended up in policy. And so now I work at Boundary Stone Partners, which is a clean energy and climate consulting firm. We do government relations consulting and grant and loan application consulting. And then as a side job, I helped form a new institute called the Institute for Transportation Decarbonization, which is more like a transportation policy think tank. So I can talk more about that as well.
That's great. Thank you. Brittany.
Yeah. Hey, so I am Brittany Bishop. As mentioned, I'm currently a program officer at Tier B. So originally I'm from Boston area and I've kind of lived all over actually. I've lived in Cleveland, Ohio for undergrad, and then I graduated from UW about a year and a half ago, so mid-2021, and I did a dual PhD in chemical engineering and nanotechnology and molecular engineering. I worked with Vince Holmberg, so I worked on fluorescent nanomaterials. So my background, I also worked a little bit with Elizabeth on some projects as well. During my time at PhD, I took about, I guess it was like 3 months off, so a quarter off, to do something called the Christine Merzion Science and Technology Policy Graduate Fellowship, which works with where I'm actually currently working, which is the National Academies of Sciences, Engineering, and Medicine. So I got to, that kind of my first official work with policy, although I did a decent amount while I was also a student at UW. And then there, though, I worked with the Board on Chemical Sciences and Technology during that fellowship. And then since then, I've gotten a position with the Transportation Research Boards. We focus on pretty wide variety of transportation topics, including like chemical transportation, like physical chemical transportation, which people don't often think about in terms of transportation related fields. And what we do is we bring together experts in whatever topic, usually Congress or other government agencies are interested in, to provide guidance and policy recommendations. So we usually send those to, like we'll do congressional briefings and send reports over to different government agencies. And so I've worked on a lot of different types of studies within transportation, like movement of liquefied natural gas by rail car. I've worked on pipeline studies, road safety, introducing plastic waste into infrastructure. So there's a lot of different types of things that we work on.
Thank you. Trevor.
All right. Good morning, everybody. As mentioned, I'm currently the flow sheet integration manager at the waste treatment plant on the Hanford site here in Eastern Washington, which is just outside the city of Richland, Washington. So I graduated from UW in 2009 with my undergraduate degree and came out here to the Hanford site in 2010 and been working out here ever since. So I'm a little bit more on the receiving end of this policy discussion than the other two panelists, but felt my role and the work that we do is highly regulated enough that I was applicable for discussion here. So the Hanford site is a nuclear waste cleanup site. It was there was a lot of plutonium production here during the end of World War II and Cold War, and most of that's been hanging around being safely stored for the last 30 or so years. And so now we're in an active cleanup mission. So my role right now is we are starting up the treatment plant, essentially waste treatment plant, to treat some of this waste and put it in a final waste form that can be put into a repository for forever. So we're currently starting up the plant in a phase we called commissioning, which is starting everything for the first time, which also means breaking everything for the first time. So it's really exciting time to be here, really challenging time to be here, and at the same time convincing our regulators, the DOE. I mean, this is a Department of Energy site, convincing them that we're the right people for the job and we're acting in their best interest. Let's see here, what else? I grew up in the Seattle area and was originally born in Edmonton, Alberta, Canada. I think that's it for me.
Thank you. Thank you so much, all three of you, for the introduction. So I have a list of questions to get us started off, but I also wanted to remind the audience to add questions in Slido as they come to mind, and we'll fold them into the conversation here. So I'd love to start off by asking our panelists, so what does it mean to work in regulatory or a policy field? So what does that mean generally? And then also, what does it mean for you? And what was the draw? So how did you end up sort of making that transition? So it's sort of a threefold question. So what does regulation or policy mean generally? What does it mean to you? And how did you sort of transition into it? I don't want to call a name, so whoever's ready to take on that question, please go ahead.
I can hop in. So I guess what policy, well, let me start with why I went into chemical engineering. As cliche as it might sound now, when I was in high school, learning about climate change was really scary. And I thought naively that I would come up with an invention that would solve climate change. Like I would come up with a new fuel and everyone would be saved. That led me down the path of eventually getting a PhD in chemical engineering and realizing that there are in fact a lot of solutions that already exist technology-wise, but we were lacking in implementing those technologies because of cost or lack of incentives or lack of regulation on other fossil fuels, for lack of a to say it bluntly. And so while I was in the ChemE program at UW, I ended up joining the graduate student Senate, or GPSS, Graduate Professional Student Senate, where I was the chair of the Science Policy Committee. And that was kind of my outlet to explore that a little bit more. And I realized that like scientists and especially chemical engineers, I think, have this unique skill set to implement policy, because we learn how to analyze data and logically think about solutions to things. And I think understanding the science behind it on top of developing those skills is actually kind of the perfect way to think about finding policy solutions for things. So I ended up doing the AAAS fellowship after that as a route to get into policy. And I don't know if anyone in the room has heard me talk about AAAS before on one of these panels, but it's a fellowship that takes PhD scientists and engineers, actually just master's degrees. If you're a chemical engineer, you don't have to have a PhD, and they place them into federal agencies and congressional offices to kind of build out those skill sets and learn how the government works, because it benefits both sides. And I would say about half of people end up staying in the policy realm after the fellowship, and I'm one of those people. So that's how I got here.
I do want to note, just saying that I think it's kind of obvious by the differences in what the three of us are doing, that regulation and policy is a really broad field, and I think broader than people kind of think about in terms of careers. So as kind of Kelly was mentioning with AAAS, there's a lot of positions directly within the government that could be federal or congressional, that could be working, directly with some sort of agency within the executive level, or working for like someone who works in Congress. But it also is pretty broad in terms of areas that you could work within industries or nonprofits. So, you could be working and providing expertise as like a policy analyst for a big company and helping them with the policy side of things. Like what I do in the nonprofit realm is more or less kind of like consulting for the government and providing expertise from the industry and the academic side to bring to the government. So I think it's a pretty broad field, and I think you can find kind of like your niche if you're interested in it, because it's kind of, I don't know, a wide range of things that you can do. So like I mentioned, for what I work within nonprofits, there are many types of nonprofits. Where I specifically work at the National Academies, we're technically an independent agency. So we were created by Congress essentially in like the 1800s at some point. We're a really old organization. So we're kind of like the official consultants to the government on a lot of areas. So as I mentioned, we'll bring together experts from, industry, from academia. For example, if I'm working on like a train study, people that work in the government aren't necessarily the ones that are actually like running the trains and, building trains and filling and unloading the different rail cars. They want to hear that expertise, and that kind of information and that science and background can help inform the policies that Congress or other government agencies, like regulations, that they put into place.
Yeah, just add my 2 cents here. I think there's a lot of power in setting policy and regulation. Again, from my end, a little bit on the receiving end, you can either help or hurt entire industries succeed, or disincentivize, sometimes on purpose, things from a policy standpoint, and how easy it is to get permitted, or easy or hard. And so really understanding the implications of the policies you're putting in place takes a level of expertise and a level of understanding of the industry that you're putting the policies in place on, that almost exceeds the people that are going to be implementing it, because there are always unintended consequences, and there's cases and cases and cases throughout history of all sorts of weird implications of implementation of policy, or the rule wasn't written comprehensive enough, or all sorts of things. So really understanding it all and understanding the industry that you're regulating is extremely important. So getting very knowledgeable people who are writing the policy can only help these industries in the goals of the government and our society.
Thank you. So I also appreciate the note that this is a very broad area, and so everyone's career trajectory might be very, very unique. And so I'd like to ask how the role of chemical engineering in your sort of day-to-day work, and then in addition to that, the role of your degree. So there's a question from the audience about whether a PhD is helpful, useful, necessary. So what is that? What is sort of like the role of the PhD there? Is it necessary to get involved in the field? What does it enable you to do? So how does chemical engineering sort of inform your day to day, and then also the role of the degrees that you see fit into that?
I can go ahead.
Go ahead.
So for me, in terms of how it informs my work, it's definitely project dependent. So my team is a variety of different backgrounds, because transportation, as I mentioned, is a pretty broad field. So we have people that work on like economics, and some people have backgrounds in like transportation engineering. I'm really the only one on the team that has chemical engineering background. So when I've been working in writing for different studies, I'll often end up writing within the past year at least like several chapters that involve specific like chemistry background. So for example, when we wrote a study on moving liquefied natural gas by rail car, I got a lot of the heavy work on doing the background on like writing the background on chemicals and like how they work in terms of like just their background and their chemical properties. And also like I did a chapter on the technical aspects of like the rail car and how like the insulation works and things like that. So it kind of is pulling not necessarily from like my specific research or anything like that, but in terms of the general background of chemical engineering, I've definitely applied it in that type of writing. In terms of the degree, I think in terms of like, especially the PhD, I think, well, a couple of things. I think a lot of positions, first of all, do want someone with a PhD. And I think a part of that is because of the skills that you learn in that role, because of just more of the writing skills that you develop writing something like your dissertation, critical thinking, all that kind of stuff that you will learn during your degree, and applying that to your job, I think is really an important factor. It's that transfer of skills and that knowledge rather than necessarily like specific things.
I can go again. I would say specifically chemical engineering, I use a bit because we have some clients and there are policies that are becoming increasingly active in the clean fuel space, and understanding just what a hydrocarbon is and how, like, what a drop-in fuel is, and how biofuels reduce carbon, just based on some of the broad general knowledge that you gain in chemical engineering, is helpful to help understand it. But also when we have meetings with like the folks at the national labs who are still doing this research, that help inform some of the policy incentives that we're advocating for. And I would say at my firm, our firm is about 45 people, and I'm the only person with a PhD at the firm. So you definitely don't need one to get a job like this. But I do think it helps. Sometimes people at my firm just like having somebody on the call with a PhD because it looks good to the client. Like we know what they're talking about. And I would say the skill set that you gain generally as getting a PhD, and also in undergrad, frankly, is being able to understand like a lot of the technical details that some of our clients are putting forward, and being able to kind of understand how that relates to the policy goals that they're asking for. So I would say I gained some of those skills through the AAAS fellowship, but being able to understand like all of the technical differences in the projects that are either applying for grants or like asking for some of the incentive money that has come out in the bills that have passed last year. Just understanding like where they plug in and what policies they should be tracking based on that technology is a skill set that I think having a PhD and just a chemical engineering background has helped kind of inform and help navigate that space a bit.
So both of you spoke to doing a lot of digging. So it sounds like a lot of like lit review, trying to figure out, the role of X and how it impacts Y, for instance. And that's a skill that you really hone through the PhD in writing your thesis, because you have to do a lot of like review, motivation, identifying gaps in knowledge. Trevor, I wanted to ask, is there a sort of a perspective that you can offer to this? Do you feel, yeah, go ahead.
Yeah, absolutely. I was going to jump in as the lone panelist here without a PhD. I mean, there's nothing wrong with a PhD, but I think there are entire industries where it is not required, and it should not be seen as something mandatory to go get a job in any field. Obviously, my field is a little less, obviously policy and research and stuff going on at the national labs is always very forward thinking and on the front edge, the leading edge of technology. We are somewhat more on the application side in building the facility and just making the equipment work. And that's not as leading edge. We've been working with pumps and valves and control systems for many, many, many years, but they should all work in theory, but when you push the button and make it go, sometimes it doesn't work so well. And we still need chemical engineers to go troubleshoot, go apply their knowledge out in the field, go figure out what's going wrong, and sometimes make design changes as necessary. So, in terms of chemical engineering, I think it's an incredibly versatile degree. I think you're able to speak knowledgeably with a lot of different types of engineers, whether it's mechanical, electrical, and control system stuff. And for me, just the application side of chemistry and chemical engineering is sort of the foundation of sort of modern society. All the amazing things these days seem to be built off chemistry and chemical engineering. So I think it's incredibly versatile.
Can I pull on that thread? So is there a single sort of chemical engineering class that serves as a keystone to the work that you do right now?
Work that we do right now.
Like, is there one where you're just always channeling this like one class to this one professor?
To me, it was all just the chemical engineering labs, and I didn't necessarily understand how important they were at the time. But really, those are the most important classes that you get, and because you get your hands on some pumps and you get your hands on some control systems, and you get for us at the time, we got to work in groups. You had to write group lab reports, and don't afraid to put that stuff on a resume, because those are all things people are going to ask about. And that's as close to working in the field as you're going to get in undergrad. So
yeah. So it's that partnership. It's working on a common problem, bringing in different ideas, different perspectives. That is.
And inevitably, there's always a lab partner that's not pulling their weight, and you got to problem solve that too.
real world experiences.
That's always a great interview question as well.
Kelly, Brittany, is there a class that sort of really speaks to what you do on a day-to-day basis?
Or
maybe a class. Okay, go ahead. Yeah.
I was going to say senior design, I think, for the similar reasons, like you had to learn to work with people, troubleshoot, and it was like a real world problem. And I don't know if this is the same at University of Washington, but at Mines we had like actual clients that had a problem to solve. And our project was making bio oil out of beetle kill trees, which is a unique to Colorado problem, but and now that's like actually a business model that some of the clients at my firm have. So it's kind of wild that 15 years later, like that's actually a commercial business.
I was also thinking about like our senior design for basically the exact same reasons. We also worked with industry, so I worked with Bridgestone tires on like rubber formulations and things like that. And yeah, that kind of, yeah, just the communication skills and having to problem solve with them and work with, you know, some people that are in your field, but some people that are not. Not everyone that we worked with were necessarily like chemists or material scientists or chemical engineers. So yeah, I definitely think that that ability to work and communicate with people outside of the STEM field, I guess in general, I think is a huge part in general of policy, because you're going to be working with so many people who just don't have that same background that you do.
So now I'm going to flip the question around a little bit. Like, is there a class you wish you had taken? Is there something that you rely on now that you maybe bypassed?
I guess I'll start with that one because I have an obvious answer. I mean, coming to the Hanford site, there's, 52 million gallons of nuclear waste sitting out in the desert out here, and we didn't take any classes on nuclear engineering. Not that I'm saying we should have, or that it's necessarily applicable to too many people, but that was definitely something I had to learn once starting here. But it's not something, when we're looking for hiring, it's not a requirement. We sort of assume people will pick it up as we move along. So.
I feel like I did a lot of this kind of on my own, but I think it's always good to continue practicing to write for general audiences. And I feel like I learned that more just doing, like, I also was on GPSS as Kelly was as well, did different types of like writing of white papers and things like that when I was a PhD student. I feel like I learned those skills through that. But I think even if you're planning to work in like a lab or more on the technical side, you're still very likely going to need to communicate and write with people outside of our field. So I think those types of classes on that kind of communication would be beneficial.
I was going to say the same thing, but I realized that I did seek out a class specifically on that. It's not in the ChemE curriculum though. So, and I cannot remember what it's called, but it's through the School of the Environment, where we had to summarize our research for the Seattle Town Hall. Oh, it's called Engage Science. I don't know if it still exists, but if it does, I highly recommend it.
So were there, sort of aside from the coursework, were there activities, extracurricular activities or experiences during your training that really helped shape your trajectory toward the fields that you're going, that you're all sort of leading?
I knew pretty early after about my second year that I wanted to transition into science communication policy realm. So I feel like I actually have kind of a laundry list of things that I did on the side to to kind of get out of the lab.
What were two that were really formative?
Yeah. Let's see. The thing that first really got me into the general, I guess, like interest of science communication and policy was working with the Clean Tech Alliance, which if you haven't gotten emails from them through CEI, they probably sent some sort of email through them or through Dan Schwartz, but they do a lobbying day where they go down to Olympia and they essentially will advocate for clean energy funding, and try to kind of like go in and tell your story and talk about why the funding will help you and help the state. And that was kind of like my first experience. And I realized they actually were really interested. A lot of the people there were in industry, and a lot of the like legislators and legislative aides were actually really interested in what we had to say as students, which surprised me. So I think that was actually the first experience where I was like, oh, they actually are like really interested in this background, and I might be able to use my expertise to do something on this side. So that's one big area. The other thing besides the Marzan Fellowship, which I already mentioned. I guess working with GPSS, I worked pretty heavily. I also worked with the Science and Policy Committee. I helped run a white paper project where I worked and helped come up with topic ideas with like the Washington State Department of Commerce and also the Washington State Academy of Sciences, and just working on those types of kind of like helping run the program, helping come up with topics, helping other students write these white papers was a really good experience in terms of learning how to lead in this space and also how to write in this space.
I think I mostly already mentioned mine, but yeah, I would say GPSS, Engage. I also volunteered at the I'm blanking on names today of things in Seattle. The Science Museum, the Pacific Science Center. I used to volunteer there a couple times a month, and you get a free pass when you do that. So it's actually really fun. But it helped me just kind of craft my science communication skills. We did like visitor surveys and stuff, so it was interesting. And you get free tickets to laser shows and stuff. So I recommend that as well.
I have another question, but I didn't know if Trevor, you wanted to jump in.
No, go ahead.
Is there a formative? Okay, so we talked about, why chemical engineering and how chemical engineering has shaped your trajectory. But I'd like to rewind a little bit and ask now, when you were in high school and then going into undergrad, how did you even learn about chemical engineering? What was there someone that you knew that it was a chemical engineer that sort of introduced you to the field? Did you just stumble upon it? Was it just like throwing darts at the wall? Or did you know what chemical engineers did and what they were? Did you what did you appreciate? What did you know? What did you not know? What did you appreciate from it? And who introduced you to that?
Gotcha. I guess I'll start with this one. So I guess in high school, I had some pretty amazing both math, chemistry, and physics teachers that were just incredibly engaging and inspiring from that aspect. So that was, I'm sure, with everybody on the panel and everybody in the room, that was a new sort of science and engineering was the trajectory pretty early on. Getting into, undergrad engineering was always on the horizon. I'd heard chemical engineering was really hard to get into, so it was always sort of this goal. Wasn't sure if it was going to get accomplished or not, but to me it was sort of it was always my first choice because I really enjoyed chemistry, and as I mentioned before, I've always sort of pictured. I know if you talk to a physicist, it's not the foundation of everything, but it feels like the building blocks of everything that we manufacture and everything we use on a day-to-day basis. So that was my way in, and I took, I think, this course actually when I was in undergrad, and liked what I heard and the range of careers that come out of it. I think was always very appealing to me.
I guess mine was similar. Like I said, I was worried about climate change, and I was good at chemistry and I was good at math, and I had really good teachers in those fields. And I just thought that meant chemical engineering was obvious. I don't think I actually knew the difference between a chemist and a chemical engineer probably till like my sophomore or junior year. But at that point, I stuck with it. And I went to the Colorado School of Mines, so it was mostly engineering. We didn't have to, I guess, get into chemical engineering. It was kind of like I declared when I got there, and I just stuck with it for another 7 years if you go all the way through my PhD.
Yeah, I think mine was also relatively similar. It's been a long time, but recalling, I think one of my high school chemistry teacher had suggested it. And when I went to Case Western in Cleveland, Ohio. And when I went on like a visiting day, they had like kind of like open houses for the different degrees. It was also similar to Kelly, where we didn't have to apply. We just kind of could declare whatever major. And I think I wasn't 100% sure actually, like what I wanted to do within science engineering, but I knew that's what I wanted to go into. And the thing that I think really appealed to me as a ChemE was because of how versatile it was. So it allowed me to kind of gain all these skills, but it still, I felt like I had the most breadth across different types of fields. So I would be able to kind of pinpoint what I wanted to do as I went through the degree. And then doing undergrad research is when I kind of honed in on nanomaterials and nanotechnology work that I did as a PhD as well.
Yeah, what you've said really resonates with me as well. I appreciated the breadth of chemical engineering, and also that it really does pull from, it is very interdisciplinary. And then actually something that was mentioned earlier that I thought was comical. So I too did not really know I knew I wanted to go into engineering, but I didn't know which, and I didn't really understand a lot of the nuances between them at the time. But chemical engineering is one of the most difficult to get into. And so it was like that challenge. I'm like, all right, I'm going to step up to this challenge. So anyway, I would now like to sort of transition forward. So you learned about chemical engineering, you had a successful academic career, you transitioned into your professional careers. Now, what is the most challenging aspect of your work today in your existing roles?
Sure. So I feel like this is maybe a common occurrence with a lot of engineers. Seems like day to day the most challenging thing is convincing everybody that you have a good idea. You'll come up with a solution, you'll come up with a project, you'll come up with a proposal, but as our two other panelists have talked about, it all comes down to communication. Not everybody's going to read the data the same way, and not everybody's going to believe you. Hey, I'm a PhD chemical engineer, trust me. That only goes so far. So you really have to communicate and convince people using their level of communication and their language that they can understand, and that is a constant challenge. I sometimes, I'm in management now, so I don't touch as much of the technical stuff on a day-to-day basis as I'd like to, but I often talk about my role as just a translator. I just try to figure out where the other person is coming from and try to translate the direct technical information in a way that somebody can understand. So that's a constant challenge. And that is not just the public in my role. That's our customer, the Department of Energy, that's our state regulators, the EPA. Ultimately, it is the public as well, because we are a government contractor. We get a lot of help from the public as well, concerned public. So it's a constant challenge convincing people that we are in fact doing the right thing out here.
And I can unpack that. Sorry to interrupt, but I feel like I can unpack that in two ways. So one, it's communication sort of up, convincing the decision makers, and then the other is communication out to the public to convince them that what we're doing with money, right, is positive and impactful in that way. So yeah, it's different languages perhaps in these different directions.
Absolutely.
Sorry, I interrupted, Brittany.
Yeah, no problem. I think for me, in terms of most challenging aspect, is that I'm working on so many different things, and each study runs maybe like 1 to 2 years. And right now I'm working on like 5 different studies. So you have to become an expert on something relatively quickly in what I do. Even though we're bringing on experts in the field, we're running the studies as staff, and we're doing a large bulk of the writing and helping direct the experts into where we go. So kind of having to know such a wide range of knowledge, and I'm definitely still learning. There's a large, as I mentioned earlier, transportation's very, very broad. So having to kind of jump between all these different projects and become a quick expert on them. I think it's becoming easier, but it's still definitely a challenge.
I'm going to piggyback on that a little bit. I think when you have a PhD, I shouldn't speak for everybody, but I feel like a lot of people realize because they learned so much about one very specific thing in a PhD, they realize how little they know about everything else. And I think that has times made my imposter syndrome a little bit worse. And I have to kind of just get over that and realize like I still do know more about a lot of these topics than like everyone else on this call. So I shouldn't be afraid to speak up and act like I know what I'm talking about, because I do. Maybe I don't have a PhD in this specific topic, but I do know what I'm talking about. I think just kind of learning how to overcome some of those doubts has been the most challenging.
So where do you all see yourselves in 5 years and 10 years? Is it still in the space that you're currently in with regulation policy, or is this sort of a stepping stone to something different? And what what are the possibilities here? Where do you go?
All right. Oh, I guess I'll start. So I guess I'll answer that question a little bit with what's sort of my past 5 or so years of my career has been. So I've been with the same company, but definitely not in the same role for basically the last 10 years. I started as a system engineer, which is just an engineer in charge of a system in the plant and the equipment there. And I've, never necessarily had a hard and fast concrete 5 or 10 year plan, but just kind of kept saying yes to opportunities and kept looking for projects or things in my purview that sounded interesting and going and getting involved, asking and getting involved. I often say to my people that if you come to me excited about a topic, who am I to get in the way? It's just my job to say yes and make that happen, because an enthusiastic employee is what we want. So if you come to me excited about a project, I'm going to do what I can to get you involved. So I've sort of just kept saying yes. So I got the opportunity to be a little bit more involved on the cost and schedule side, see how all of that works for a federal contractor, which was there's a lot of regulation involved there too. So surprise, surprise. Then got to be on the program side, setting up our processes and procedures and training for engineering, implementing a lot of government policy there in our engineering program. And now finally, over the last couple of years, back to a little bit more of the technical side on the flow sheet integration as flow sheet integration manager, which is batch chemistry in the plant and in charge of the product chemistry of the glass that we make. So that's really scratching my itch right now of the technical side. But I don't know where the next steps are, but I'm open to opportunities and excited to see what happens out here on the site in general.
It does sound like empowering new projects and new people is definitely part of that vision.
Absolutely.
At least how I'm interpreting what you're saying. That's great. That's awesome. Kelly and Brittany, what is your sort of long-term goal, or where do you see yourself going?
Yeah, I guess similar to Trevor, I feel like I kind of just go with the flow, and especially when you work in policy, like I don't know what policy-wise is going to be happening in 5 years, but I could just I guess I'm open to riding the wave. So like, for example, when I started in the policy field, I was mostly working on like electric vehicle policy. And now, kind of like I said, the biofuel space is kind of picking up for aviation and other heavy fuels. And so who knows, like maybe I'll get more involved in that in the next 5 years, and that will be our base client. Or maybe something will happen in politics, which I would say is another challenge that I didn't mention in the last question. Politics. Maybe something will happen in politics where I'll decide to go back and work at the Department of Energy or something. But mostly just like being open to changing career trajectories. I think I do want to stay in the policy space because I think it's valuable to have engineers and scientists in that space as things are changing, but being willing and able to be flexible, I think.
I feel like I'm exactly on the same page, especially since I've only been in this job for a little over a year. I'm still getting to know what aspects I like and don't like, and thinking about, next steps. So yeah, I'll just leave it at that.
So any insights that you might want to share with regard to balancing the tension, the healthy tension, I should mention, between breadth and depth? So this is a question from one of the students. We've talked about some healthy tension sort of between communication and sort of technical fluency, right? That these are distinct skills. But what about just the academic breadth versus depth? Which one? What are the pros and cons versus prioritizing one over the other? Or what do they enable if it's not a pro and a con? What is the breadth enable versus the depth?
Yeah, well, I guess from my perspective, the first thing to acknowledge is you're not going to learn everything in school. I mean, even with an undergrad ChemE degree, it was I view it as an amazing foundation. But like I said, it was not anything specific to my field, and there's always going to be a learning curve in any industry, even just with corporate policy on how they do things. There's going to be a learning curve. So just acknowledge that when you get the degree, I'm not discounting it. It's amazing. It's an amazing accomplishment. But there's still work to be done. There's still lots of learning to do, and apply those lessons on how you learn and how you learn about a new topic to whatever field you dive into. I guess specifically the breadth and depth, I've found my role as a bit of a generalist. That's not to say we don't have subject matter experts in my group that have found a role for the 45 years of their career as specifically waste cleanup glass chemists, and who knew that was an expert you needed, but we have 3 or 4. So there's roles in each, and you need both in all sorts of different situations.
Yeah, I'd say in the policy space, breadth helps. Like the more you realize how things interact with each other, like for example, the grid and vehicles and housing, like how that all impacts our carbon emissions from transportation. I'm using examples very specific to what I do, but the longer you go in your career, the bigger the breadth will get. And I think the skill that you develop in the policy field is learning how to go in depth enough to get the answer that you need to make the policy decision, and not like getting too into the weeds where you're maybe wasting time on things that you don't actually need to know. Like you could just ask an expert for those things, but like understanding enough how the pieces work together and impact each other in depth enough to realize like the outcome of the action you're about to take.
Yeah, I don't think I have too much to add.
Okay.
I think this for where you focus is just kind of, like we said, what you want to do. If you generally know what your career is or where it wants to go, if you're more interested in that kind of regulatory policy side, then working on those skills and understanding that breadth is important. If you know that you really want to focus on a specific technology, then the depth is what's important there.
But what does sound to be consistent, though, is that we recognize that engineering is not static. And so we're always needing to learn in each of these fields. And what we learn through the academic experience is how to learn. So it's not that it ends with the degree and that you're no longer learning, but it's really like embracing this is how I take on a new subject matter, and this is how I can become more of an expert and become more fluent. So I love that in engineering, that it's flexible and adaptable and constantly evolving. But so I have to say that unfortunately we are out of time. And so I wanted to thank you so much for taking the time that we have had together to answer some of these questions. It's been really great to get to know you and your field.